Okay, so like we said, this is Earth's dimensions. So you're going to be learning about the parts of the Earth. Can you guys see the screen?
Yes.
Okay,
Yes.
perfect. Thank you. If you guys have any questions at any point, just unmute yourselves. All right. So there are 4 parts to the Earth. All right. They are made up of the geosphere, the atmosphere, the hydrosphere, and the biosphere. Now, those 4 parts, we're going to get into more detail explaining them, but this is just a list of them. Just like we said earlier in the year, science uses the same prefixes over and over and over again and puts them with other words to describe specific things. So when we go through each of them, I'm going to have you guys actually tell me what you think the prefix sounds like, right? We're going to say that it sounds like something because in word association works really, really, really well with earth science, okay, in case you don't know something. Okay, so let's talk about the geosphere, right? Geosphere kind of sounds like what?
Geography.
Geography, right? It sounds like geography, right? So what is geography?
It's about like
The land.
It's what?
About the land.
Yeah, it's about the land, right? So geosphere is going to be talking about the solid earth. Now, solid earth is kind of it's not 100% because not all of the earth is solid, because we're talking about the interior layers of the earth from the surface where we live to the center of the earth, which is the core. Okay. This picture here is a rock formation in Arizona. Okay. Notice how it's way, 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 way bigger on the bottom than it is on top. And someone pointed out to me this, it looks like a creepy lady standing sideways right here. Okay. That does actually happen from when the elements that are around them will interact with each other. So the geosphere, the atmosphere, the hydrosphere, and the biosphere all interact with each other in different ways. In this case, it formed these rock formations that were pulled up from the center of the earth at one point and creates these little people, which are super creepy but amazing at the same time. This is a picture of the interior structure of the earth. So in the very center, we start with the solid core, the inner core. Okay. Most of this is on the reference table. What's not on the reference table is the state of matter that they are in. So you have the inner core, which is solid, then followed by the outer core, which is liquid. Then you have the mantle. The mantle is this entire red section here. Okay. You have the lower mantle, which is most of the mantle, and then there's the upper mantle. Then in this little tiny sliver is what's known as the asthenosphere and the lithosphere. Okay. Here's a better picture of the asthenosphere and the lithosphere. The asthenosphere is the mantle, and you see how it is partially molten, and that's because some of it is actually in liquid form and some of it is in mostly solid form, and when you put them together, basically you get that chocolate syrup consistency. If you've ever had, chocolate syrup or made chocolate milk with chocolate syrup, it comes out really slow. That's what molten kind of looks like. It's just so you guys can visualize it a little bit better. Okay. Then the lithosphere goes from the mantle to here. Okay. Then we have the oceanic crust, and then we have the continental crust. So let's look at it on your reference table. Now, I'm going to be showing you a bunch of reference tables over the next couple of minutes, all right, through class. So if I were you, not only would I have my reference table out, but I also would be jotting down which reference tables specifically you're using. Why am I telling you to do that? Because in a test setting, I'm not going to tell you what page to look at. So you're going to have to know and break down what the page is, what's going on, so on and so forth. And you're using the one on your iPad right now because remember, that one is not a clean copy. That one is the one that we are going to be writing all over. I'm going to warn you, right now, there's not going to be a lot of notes on the PowerPoint, so you're going to have to listen and take notes. Okay, So first thing I want to point out about this graph is that it says inferred properties of Earth's interior. So it doesn't say geosphere. You have to know that the geosphere is talking about the Earth's interior. Otherwise, you're not going to know to look here. Okay? It tells you that the inner core is made up of iron and nickel. The outer core is made up of. It doesn't tell you what the stiffer mantle is. Doesn't tell you what the asthenosphere is made up of. So on and so forth. But what it does tell me is on the right-hand side here are all of the density ranges. And the reason I say density ranges is because they are not 100% sure which way the density is, but somewhere between 12.8 and 13.1 has been registered for the inner core. And this should make sense because when we talked about density, the heaviest stuff should be at the bottom, right? Because technically, even though this is a sphere, right, if I look at it this way, right, the inner core would be the bottom, then the outer core, then the mantle, then the asthenosphere, then so on and so forth, okay? The lithosphere here is made up of the crust and that rigid mantle, okay? So it's the outer part, right? The crust over here is made up of either the continental crust, which is where we live and build houses, or the oceanic crust, which is at the bottom of the ocean. Okay, so the lithosphere is here, right? But the crust information is here, all right? So this little tiny thin line, the thin black line here, that's where we exist. So all of this other stuff is not where we are. So people think we take up a lot of the Earth. We really don't. Okay, so let's move on to the atmosphere. Yesterday in class, we watched a video clip, and the scientist decided he was going to go in the airplane, and he went up into the air. Well, he went through gases, right? Even though you can't necessarily see them, right? You just have to know that he went through gases that surround that hard Earth. Okay. Now, I love this picture because it's bright and it's colorful and it's all kinds of other fun stuff, right? Notice here, there's this little plane, right? Notice that the plane is right above what's known as the troposphere, okay? There are 4 layers to the atmosphere, and they all end up in sphere. So it's troposphere, stratosphere, mesosphere, thermosphere, okay? The white lines that you see here are actually the interfaces. Remember how I told you that interfaces, there are ones that you can see and there are ones that you cannot see? Well, these interfaces you cannot see. You're not necessarily going to see a line at certain altitudes as it's separating each one of the parts of the atmosphere. Now, do you have to memorize this? Absolutely not, because it's in your reference table on page 14. Oh, before I forgot, I actually did forget. On page 10 of your reference table, sorry about that, I forgot for a second. Where did it go? Here it is. Okay, page 10 of your reference table is not just this top section. It's these bottom 2 sections as well. So if I was to ask you how big, okay, or how deep is the stiffer mantle compared to where we are located? Do you guys all see these dotted lines? Hopefully you do. Okay. Yeah. They basically are helping you to read down to the depth, right? So up here, this is where the stiffer mantle is. If I follow this dotted line straight down, right, the depth of the stiffer mantle is going to be between, I'm guessing this is about 600 kilometers to just shy of 3,000 kilometers here. Okay, so that's how you're going to read this chart. The chart also has on it temperature. So this graph down at the very bottom, this square down here, is temperature versus depth. Okay, and this square here is pressure versus depth. So the dotted line will actually help you to see exactly which section we are talking about, right? Notice they all have units, right? Pressure is in atmospheres. Atmospheres are a pressure unit. The other day I mentioned torr as well. right? Temperature in this case is in degrees Celsius. Why? Because nobody in the world uses degrees Fahrenheit except for the United States. Everybody else uses the other. Okay, so sorry about that. So when you are looking at this reference table, right, again, you need to dissect it. You need to look at it. What is its title? What are the units? So on and so forth. Well, this is a 3-in-1. The other one was a 3-in-1 as well, but it's a little bit different. This is 3 different graphs in one chart. So you see how it says selected properties of the Earth's atmosphere? In this case, it's telling you that it has to do with the atmosphere. So you don't really have to memorize the fact that the atmosphere is the gas layers because it is on your reference table. Okay? Again, you're going to look at the y-axis first. Notice how it's in both kilometers and miles. Be very, very, very careful while you are actually doing this, because if it asks you for the answer in miles and you're looking at kilometers, it's completely different. The next thing you want to look at is sea level. Sea level is at 0 kilometers above the Earth, okay? There are places that are below sea level. Does anybody know of one that's inside the United States?
New Orleans,
New Orleans. What state is that in?
Louisiana.
Yeah. So Louisiana is actually below sea level. So it would be down here. Okay. That's also why New Orleans and Louisiana in general flood all the time. Has anybody ever been down to New Orleans?
Nope.
Okay, thank you. Okay, so none of you have been to New Orleans, but I will tell you, my aunt is from there. She's from Slidell, Louisiana. Okay, in Slidell, they have a lake called Lake Pontchartrain. Depending on if it's high tide or low tide, you can cross Lake Pontchartrain. If it's high tide, you cannot cross it. Why? Because the water comes in and actually floods over the bridge. Okay, they also have, if you ever get a chance to go down there, they have all of the cemeteries or mausoleums. And again, the reason for it is because when the tide comes in, if everybody was buried in the ground, you'd have coffins rising up all the time. So instead they have mausoleums, which are basically those cement little houses. Sometimes they're very large, depending on how big your family is, but it's basically where you can house the dead after they die. Okay, so I digress a little bit. What's up?
What about the Niagara Falls?
What do you mean?
Wouldn't that be below sea level too? Or
Wouldn't that be what?
below sea level or no?
I'm not really sure if Niagara Falls is below sea level, to be honest with you. But we can find out. Let me find out and I'll get back to you, okay? We'll Google that real quick. All right, so on the left-hand side here, we talked about sea level. We also have to look at what each one of these tick marks means, right? Right? So when you were looking at this, right, on the left-hand side in kilometers, you have 3 tick marks between 0 and 40. That's going to tell me that each one of these tick marks is worth 10. Whereas on the right-hand side, you have 4 between 0 and 25, which is going to tell me each one of them is going to be worth 5. So be very, 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 very careful, okay, when you're looking at it, that you don't automatically assume that both of them have the same measurements. And I just looked it up. Niagara Falls is above sea level. Okay, so we have our first graph is temperature versus altitude. Our second graph is pressure versus altitude. And our third graph is water vapor concentration versus altitude. So let's first look at the temperature. Okay, again, you see the troposphere, the stratosphere, the mesosphere, and the thermosphere, and each individual interfaces that separate them. Now, again, they get separated by altitude, and you have to be able to read the graph, so be very careful, okay, when you are looking at them that you either continue the line over to the left or you use some sort of straight edge, right? Inside the troposphere, you notice that as you increase the altitude, the temperature decreases, which should make sense to you. If anybody has ever gone skiing before, or to Camelback, or to Great Wolf, right? They actually have colder summers than we do. Why? Because they're up in the mountains, right? So I was there 3 or 4 years ago in August, and it was supposed to be 90 degrees, and it turned out it was 60. It's the same temperature as pretty much it is outside. You're trying to go to a water park that's not really good. Okay, so it was more of a mess, but it was still fun. But that's a direct relationship between temperature and altitude. Okay, it doesn't matter what section you are in. If you're in the troposphere or the mesosphere, it's an indirect relationship. If you're in the stratosphere or the thermosphere, it's basically a direct relationship between the two of them. But you don't need to memorize it because it's on this graph. Okay, the second one is atmospheric pressure versus altitude. And we notice as we go up, now ATM down here, guys, stands for atmospheres. Okay, it's a unit of pressure. There are also some other ones that you're going to be responsible for knowing, but right now it's not a big deal. Just know that atmosphere is just a part of the pressure units. It's just one particular one. All right. So when you're looking at it, what kind of a relationship is this between pressure and atmospheres, or I should say altitude? Is it direct or indirect? As you increase the altitude, what's happening to the pressure?
This indirect.
It's going down. So is that a direct or an indirect relationship?
Indirect.
Indirect, right. So it's an indirect relationship. As one increases, the other decreases. That's also why, guys, if you've ever gone in a plane, right, you'd be right about here, okay? As you increase your altitude, your ears start to get clogged, and you either chew gum and swallow, or you hold your nose and like kind of blow out is the best way to put it, and you fix the pressure, and then they depressurize the cabin, right? So that basically that the outside pressure and the inside pressure are even enough so it doesn't hurt you, okay? And it does go in the other way. If you go below sea level here, like if you try to go down to see the Titanic that sank, let's just say, okay, you spend like 4 hours slowly descending, because if you didn't spend 4 hours slowly descending, the pressure that would surround you would be so great that it would break the windows in whatever vessel you were using to come down, and you would drown. Hopefully that never happens. Also, usually the windows are super thick for that reason as well. Okay, the last one is water vapor over here, right? Water vapor is what makes up our clouds. So if you notice, this is again an indirect relationship between the concentration of water vapor and the altitude. So our clouds and weather are basically going to happen a majority of the time in the troposphere, maybe a little bit in the stratosphere, but it will mostly happen inside the troposphere, because that's where our water vapor is. Without water vapor, you will not have clouds, which then form and fill up with more water and eventually pop, and that's how we get rain, like it was raining this morning and last night. All right, any questions on page 14? Okay, moving on.
No.
Now we have the hydrosphere. Hydrosphere, what do you think it has to do with?
Water.
Exactly. It has to do with water, right? Does anybody know what percentage of the Earth is made up of water?
75.
80.
Too high. What do you think?
70.
It's
78.
70. Very good. Okay, and what percentage of that 70% is actually fresh drinking water?
2,
Close. Go higher.
3.
3.
5.
Okay, so approximately 70% of the Earth's surface is covered in water, but only 3% of that water is stuff that we can drink. Right? That's a huge issue for us if you think about it, right? Because if it's only 3%, now that's fresh water in general. That doesn't mean that it's clean drinking water, right? That just means it's not salt water, because if you drink salt water, you actually dehydrate yourself from the inside out. Fresh water in general is just the water that doesn't have salt in it. Now, out of that 3%, probably maybe 7 or 8% might be clean drinking water without us having to purify it in some way, right? We've all seen those commercials where there's these little kids who they're trying to raise money for them because they have no clean drinking water because all their water has dirt in it, or it has other particles, or you just don't know what's in it, right? This is why. So name some places where we can find water.
A lake.
A lake. What else?
The ocean.
The ocean. Very good. What else?
The sea.
The sea. Go ahead. What else?
The ground.
Pond.
The ground. A pond. Good. You're missing one big one, guys.
A springs?
No.
A river?
Us?
River. Yes.
The ocean?
You said the ocean.
Waterfall?
Waterfall too. Okay, but you're still missing one really big one.
Mountain.
Clouds.
A lake?
Rain.
You guys said all this stuff already.
Mountain.
You ready? The one that you're
Did we say
missing.
river?
Is it us?
The sink?
Wait,
Lake.
the faucet. The faucet.
Sink.
The faucet.
I love how enthusiastic you guys are. I'm loving teaching from here right now. This
Did
is
we say the
fantastic.
river yet?
Yes, they said the river.
Lake.
You guys have to remember that it's liquid and solid water. What is solid water?
Ice.
Glaciers. Glaciers.
Exactly.
Oh,
So
I'm
when you're
smart.
looking at this, you guys are so smart. I love it. Okay? You said the oceans and lakes and rivers, and actually you guys are the only class so far that has mentioned groundwater. Very good. Very proud of you guys. The only one you missed was ice. Ice still does take up a huge portion of the Earth. We have the North Pole, we have the South Pole, right? The high altitudes in general, at the very, 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 very tippy top of a mountain. Sometimes you see snow up there, right? And that snow, sometimes on top of that is some ice. All of that makes up the hydrosphere. So it's any version of water on the Earth, okay? Except for water vapor, all right? That's the only thing you just want to make sure that you understand, because water vapor is technically a gas, and that would be part of the atmosphere. Good job, guys. All right, I'm going to move to the next one. Anybody?
Wait.
Okay. That's why I ask. Let me know when you're done, okay?
Oh, damn. My mic is still unmuted.
You guys good?
Almost.
Okay. Let me know when you're done.
Okay, done.
Okay, awesome. So on page 1 in your reference table, all right, this is at the bottom of page 1 if you guys are looking at it. It says the average chemical composition of the Earth's crust, hydrosphere, and troposphere. First of all, you need to know that chemical composition, okay, basically explains what it's made up of. Anytime you see the word composition, it means what it's made up of. Okay, the fact that it's saying chemical, it just means the different types of elements. I would absolutely make up flashcards and know the elements and their symbols. Okay, so that you can basically guess really quickly what the element I'm talking about. If I just say O, you should know it's oxygen. Okay, so this looks like a lot of numbers and a lot of words put together, but it actually makes sense. Okay, so we have the crust over here, and it says percent by mass and percent by volume. Then you have the hydrosphere, which is percent by volume, and then you have the troposphere, which is also percent by volume. Okay, so what is percent by mass and percent by volume? You've probably heard percent by volume before. Now, you guys are all under the age of 21, so you are not allowed to hold or partake in an alcoholic beverage, but there may be a parental unit in your house that is allowed to because they're over 21 if they choose to. On the side of this beverage, it says percent alcohol by volume. Okay, don't worry, I'll bring it back to this afterwards. The reason it says percent alcohol by volume is it's telling you that out of the entire container, what percentage is made up of alcohol. Most of them are pretty low, okay? But the way that they figure it out is they take the volume of the alcohol over the volume of the whole entire thing and multiply that by 100. So I'll say it again. The formula for percent by volume is going to be the volume of the part over the volume of the whole, and that whole thing is times 100.
Can you repeat that?
Absolutely. Here you go. Can you see it? Let it go in. Focus in. Focus. No, of course not. Hold on. I lowered my brightness before and it worked. Can you see that yet? Come on, focus. Focus. No, doesn't want to work.
Can you screenshot
There
it?
it is. Okay. So when we're talking about percent by volume, we're talking about the volume of the part over the volume of the whole times 100. Percent by mass is the exact same thing, but instead of saying volume, you say mass.
Can I take a picture of that?
Absolutely.
Wait, it's blurry again.
Oh, I see. Oh no. Focus.
Can you put a screenshot of it on Google Classroom?
I can try. Why is it not working? There you go. Quick.
It's not working.
Wait, I got it. Wait. Keep it like that. Wait, never mind.
No, it's still blurry.
There you go.
I'd
Okay,
say your
It's
best
still
bet
blurry.
is
It's not working.
I'll try it another way. So basically, guys, it's the volume of the part over volume of the whole times 100. So what that does is that tells me that out of the entire container, and this is my seltzer, okay, out of the entire container, how much of it is made up of, let's say, chocolate syrup, okay? So that's what that does. Now, when it comes to the reference table, like I said, page 1 of the reference table, right down here, right, it has the percent by volume. So the crust in percent by volume is made up of mostly oxygen. Majority of it, 94.04% of the entire crust is oxygen. Then followed by silicon, then followed by, oh, sorry, not silicon, I lied. Then followed by potassium, okay, then calcium, then sodium. So this is not put in number order, guys. So be careful of that. I believe it's put in number order for percent by mass, but nothing else is in number order, okay? So be careful. They love to ask you a question on the Regents that says, What is the second highest percent by volume in the crust? Now, everybody assumes that it's silicon because it's the second number, but 0.88 is much less than 1.42. Okay? The other thing is, in the hydrosphere you guys just told me was made up of water, right? Water's chemical formula is H2O, right? Which tells me that I have 2 hydrogens for every 1 oxygen, which makes sense why the percent by volume of hydrogen is double that of oxygen. Does everybody see that? Right? It's because water is H2O, which means you need double the amount of hydrogens that you have oxygens, which is why the percent by volume is doubled. Okay? Sure.
For the mass percentage, what was the thing under mass part?
So it's mass of the part over mass of the whole times 100. It's always part over whole times 100, whether it's volume or mass.
Okay, thank you.
No problem. So in this case, when we're talking about percent volume, right, the part would be the volume of the oxygen over the volume of the oxygen plus the hydrogen times 100. That's how you would figure this out.
So for the oxygen, like you would need more oxygen less oxygen or more?
Right. Because if you look, hydrogen in water's chemical formula, it's H2O. That tells me I have 2 hydrogens for every 1 oxygen. So in order for you to have a hydrosphere, which is made up of all water, you are going to have 66, you're going to have double the amount of hydrogen for every, than you would oxygen for that reason. So you have 66% hydrogen and 33% oxygen because it's H2O. You need double the amount. Now, really quickly, guys, the troposphere is mostly made up of nitrogen. So I want to get through the last sphere before I have to let you go. This slide right here has a lot of terms on it. Take a picture really quick. But you know most of these words. You told me what groundwater is. It's basically water that has seeped into the ground through a process known as infiltration. Evaporation is when the water becomes a gas, the liquid water becomes a gas, right? And it will condense up in the air to make clouds. Precipitation is where that water comes back down to earth. Runoff is when it literally will run off of the earth into a body of water. Okay. Transpiration, you guys learned last year. The best way to explain it is it's evaporation off of plants and trees and anything green. Okay. And then sublimation is when you go straight from a solid to a gas. You completely and totally bypass the liquid phase. This is the last thing, and then you guys can go. So biosphere is every type of life, from the smallest cells, protozoan, to people. And in this picture right here, right, it's showing how every single sphere will interact with each other. We have our water buffalo here, which is part of the biosphere. We have the the crust here, right? We have the geosphere stuff. We have the hydrosphere, and all around them are the atmosphere. So all of the spheres interact with each other all the time. All right, guys, that's the end of my lesson for today. I will see you tomorrow. You guys have about 5 minutes to get there to your next class, all right? You guys have a good one, and I will see you tomorrow. If you have any other questions, guys, the email is down, but you can post on Google Classroom, okay?
Miss Gonzalez.
Thank you.
Yes, ma'am.
So when the first lab, the safety lab was due,
Right.
I forgot to submit it to turn it in, and I realized it that same day later on, and I emailed